In this video, we will be demonstrating the bending moments in a beam experiment, the STS2, from the Next Generation Structures range by TecQuipment. This experiment illustrates and proves the basic theory of bending moments in a beam. Most structures use some form of beams, such as floors and ceilings of buildings, decks of bridges, or the main parts of industrial cranes and large machines. Engineers need to be able to predict how a beam will behave. Using this experiment, the student uses a purely mechanical method to calculate the bending moment. Let's take a closer look around the experiment. This is one of 21 experiments that mount on the structures platform and connect to the automatic data acquisition unit and VDAS software. We have here the experiment mounted on the structures platform with the beam connected to two supports fastened in place like this. The support on the left has a load cell which plugs into the digital interface hub on the platform. The first experiment allows students to explore how a change of load affects the bending moment at the cut. Masses are added, measurements taken, and more weights added until a full set of data is gathered. This can be captured within the VDAS software, or readings can be manually taken from the software and recorded in other ways. From here, you use the following equations to work out the bending moment for each load and then chart them to confirm the relationship between load and bending moment. The second experiment allows you to look at the bending moment of multiple loads and the principle of superposition. Let's start with the multiple loads. We put one load to the left of the beam, record the bending moment, then remove and put it over to the right and record the reading. Next up, add 500 grams to both of these points. Now you get to analyse how the loads compare. The theory of superposition, which is, for all linear systems, the net response caused by two or more stimuli is the sum of the response that would have been caused by each stimulus individually. This can now be scrutinised, testing students to see, have their results proven this? The third experiment examines moving load points along and allows you to plot an influence line. With this, you move the load along the different positions of the beam, taking the readings. Then create 3 single point loads of any weight and apply to 3 different positions. Then you record your moment reading. With this, students can calculate the influence value and create a chart of influence. The fourth experiment is for studying the bending moment on a uniformly distributed load. For this, the uniformly distributed load bars are put on top of the beam between the two supports, leaving a small gap so they don't touch at the cut. Students can then run an experiment similar to the experiments above and see how a distributed load cell affects beam bending. That's it for the experiment. You also might like to investigate the bending moments in a portal frame experiment, the STS2, or the bending stress in a beam experiment, the STS5. Web links for all I've mentioned here today can be found below, or simply enter the name into the search box of the TecQuipment website. Don't forget to like and subscribe to the TecQuipment YouTube channel for the latest videos and live stream events. And for some fun and engaging short videos for students, check out the TecQuipment TikTok account. If you're fond of emails, you might also like to subscribe to our newsletter. Thanks for watching.